NASA and Lockheed Martin formally debuted the agency's X-59 quiet supersonic aircraft, a one-of-a-kind experimental airplane designed to gather data that could revolutionize air travel. With this innovation, NASA aims to pave the way for commercial aircraft that can travel faster than the speed of sound without causing disruptive sonic booms. This is a major accomplishment made possible only through the hard work and ingenuity from NASA and the entire X-59 team, said NASA Deputy Administrator Pam Melroy. In just a few short years, we've gone from an ambitious concept to reality. NASA's X-59 will help change the way we travel, bringing us closer together in much less time. Melroy and other senior officials revealed the aircraft during a ceremony hosted by prime contractor Lockheed Martin Skunk Works at its Palmdale, California facility. The X-59 is central to NASA's Quests mission, which seeks to provide data that could lead to regulatory changes regarding supersonic travel over land. For decades, the U.S. and other nations have prohibited such flights due to the loud and disruptive sonic booms. The X-59 is designed to fly at Mach 1.42, 900 to 25 miles per hour, while generating only a quiet sonic thump. It's thrilling to consider the level of ambition behind Quests and its potential benefits, said Bob Pierce, Associate Administrator for Aeronautics Research at NASA headquarters. NASA will share the data and technology we generate from this one-of-a-kind mission with regulators and industry. By demonstrating the possibility of quiet commercial supersonic travel over land, we seek to open new commercial markets for U.S. companies and benefit travelers worldwide. With the rollout complete, the Quests team will now focus on the next phases: integrated systems testing, engine runs, and taxi testing in preparation for the X-59's first flight. The aircraft is expected to take off later this year, followed by its first quiet supersonic flight. Initial flight tests will be conducted at Skunk Works before transferring to NASA's Armstrong Flight Research Center in Edwards, California, which will serve as its base of operations. Across both teams, talented, dedicated, and passionate scientists, engineers, and production artisans have collaborated to develop and produce this aircraft, said John Clark, Vice President and General Manager at Lockheed Martin Skunk Works. We're honored to be a part of this journey to shape the future of supersonic travel over land alongside NASA and our suppliers. Once NASA completes flight tests, the agency will fly the X-59 over several selected cities across the U.S., gathering public input on the sound it generates and how it is perceived. The collected data will be provided to the Federal Aviation Administration, FAA, and international regulators. The X-59 is not a prototype but a unique experimental aircraft designed to inform the development of future quiet supersonic aircraft. At 99.7 feet long and 29.5 feet wide, its distinctive shape and technological advancements enable quiet supersonic flight. The aircraft's long, thin nose, which accounts for nearly a third of its length, disrupts shock waves that typically cause a sonic boom. Due to this design, the cockpit is positioned almost halfway down the aircraft and lacks a forward-facing window. Instead, NASA developed the External Vision System, XVS, a set of high-resolution cameras that provide a real-time 4K monitor feed in the cockpit, ensuring pilots have an unobstructed view. Additionally, the X-59 features a top-mounted General Electric F414 engine, producing 22,000 pounds of thrust. The smooth underside of the aircraft prevents shockwaves from merging and generating a sonic boom. The Lockheed Martin X-59 Quests, quiet supersonic technology, also known as QSST, has been in development since 2016. Originally, flight testing was planned for 2021, but after delays, The aircraft is now scheduled for delivery to NASA in 2025. It is expected to cruise at Mach 1.42, 1,510 kilometers per hour, 937 miles per hour, at an altitude of 55,000 feet, 16,800 meters, generating an effective perceived noise level, EPNDB, of just 75, comparable to the sound of closing a car door. Lockheed Martin was awarded a preliminary design contract in February 2016, with initial wind tunnel testing conducted from February to April 2017. NASA awarded Lockheed Martin a $247.5 million contract in April 2018 to design, build, and deliver the low-boom X-plane by late 2021. By October of that year, NASA Langley completed wind tunnel testing on an 8% scale model, examining stability, control, and dynamic forced oscillations. By 2019, major structural components were being assembled at Lockheed Martin's Palmdale, California facility. NASA Langley also tested the external vision system XVS on a King Air aircraft. In September 2019, the critical design review was completed, followed by further assembly milestones in 2020. In November 2022, NASA installed the General Electric F414-GE-100 engine on the X-59. By August 2023, the aircraft was seen rolling out of a hangar, and in January 2024, it was officially unveiled. With the aircraft's engine undergoing its first test in November 2024, the X-59 is on track for its first flight in 2025. NASA will then conduct city overflights, gathering public feedback to determine the acceptability of quiet, supersonic travel. These findings will be delivered to the International Civil Aviation Organization, ICAO, and the FAA in 2027, potentially leading to a decision in 2028 to revise existing regulations on commercial supersonic travel over land. Propelled by a General Electric F414 engine, the X-59 is expected to reach a maximum speed of Mach 1.5, 990 miles per hour, and cruise at Mach 1.42, 940 miles per hour, at 30 degrees Celsius, 55,000 feet. It features a Northrop T-38 cockpit, ejection seat, and canopy, along with an F-16 landing gear. The aircraft's long, narrow airframe and canards help maintain low boom characteristics, reducing noise levels to around 75 EPNDB, significantly quieter than the 105 to 110 EPNDB of the Concorde. To enhance pilot visibility, the X-59 is equipped with Collins Aerospace's ProLine Fusion cockpit avionics and an Enhanced Flight Vision System, EVS. The EVS includes a high-resolution forward 4K camera with a 33 degrees by 19 degrees angle of view, compensating for the lack of a forward window. Beneath the nose, the Collins EVS 3600 multispectral imaging system assists with landing, while the NASA-developed XVS provides a digital forward view. As the X-59 prepares for its first flight, the world watches closely. If successful, this experimental aircraft could transform the future of commercial aviation, making supersonic travel over land a reality without the disruptive noise of past generations.